Hi everybody, I'm so happy to see you. Today we're going to talk about parts per million, ppm. So a little bit of background information. This is an expression of concentration of a solution. So like when you think about molarity, percent volume, percent mass, it's in that same field where we're asking ourselves how much solute is dissolved per unit of solvent or solution in essence. Now, a percent concentration, so when we do like mass percent, that's actually a parts per 100. We're asking how much solute is there per part of 100 pieces of solution or solvent. So that's a part per 100. We're asking part per million, which means I'm saying if I have one little piece of, let's say, magnesium compared to 1,000 pieces of solution, so really small. Parts per million is really, really small. You can also have parts per billion, we call that ppb, or parts per trillion, that's going to be ppt, super, super small. Because these concentrations are so small, you see them in unique situations. A really good example of this is drinking water in our water chemistry. Where you live, it's possible that a report is produced every year for the potable water, the drinking water, and they'll give ppb, ppm for different particulates, maybe how much lead is in the water, how much E. coli is in the water. And of course we want extremely, extremely small amounts of those in our drinking water. We don't want those going into our body. So drinking water, you will see ppm as our unit of concentration. Now, you can use parts per million with mass or with volume. There's one little trick in this that I want to remind you about, and it is the density of water. Remember, the density of water is 1 gram per mil. 1 gram, the mass of 1 gram of water takes up a volume of 1 mil. So if our solution is water, if our solvent is water, that we've dissolved our solute into the solvent, which is water, so the total solution is made up of water and dissolved solutes. 1 gram of water equals 1 mil. So we could say 1 gram of that solution equals 1 mil of the solution. Kind of a little trick that we use with the density of water. If the solute, what we dissolve in, is water, and often that's what our solute is water. So let me give you a couple of formulas, all the same formula, just slightly changing the units. Here's the key. As long as the unit's the same on the numerator and denominator, you're great, with one exception. So ppm, you can have the mass of the solute, so that's what's being dissolved. Notice I put that in grams, divided by the mass of the solution, that's in grams. Now to bring that to a ppm, all you have to do is multiply by 10 to the 6th, multiply by a factor of 1,000,000. And if you're thinking about percentages, traditional percentages, if I say, hey, what's the percentage of girls in a classroom? I would take 20 girls divided by 30 boys, and it would come out 0.667. What do I do to make it a percent? I multiply it by 100. That's your pp, your per 100 right there. Well, ppm, instead of multiplying by 100, you multiply by 1,000,000, and that brings it to ppm. That's it. That's all it is. Rather than bringing something to a percentage, multiply by 100, we bring it to ppm, multiply by 1,000,000. That's it. Now, you can also use volume, but you have to be really careful that you have the same units. So I could have the volume of a solute, that's mils, divided by the volume of the solution, also in mils. So those units have to cancel so that we have that ratio of the solute to the solution. And then again, here's the key to bring it to ppm, multiply it by 1,000,000, multiply it by 10 to the 6th. Now, couple of tricks in this. Remember, if the solvent is water, we can use our little trick with density of water, where a gram and a mil are the same thing. It's 1 and 1, right there, 1 gram per 1 mil. So if I'm using ppm of a solution and that solvent is water, look what we can do. We can take the mass of the solute in grams and divide it by the volume of the solution in mils. Because remember, 1 gram and 1 mil are the same thing for the density of water, and then multiply by 10 to the 6th. So every once in a while, you might see scientists use that little trick where they will take the mass of the solute divided by the volume of the solution, but in this case, you'll need to have the grams and the mils. Another fun little trick. So this parts per million, we multiply by 10 to the 6 to get it to that millionth. Notice what you can do here. You can have the mass of the solute in milligrams divided by the mass of the solution in kilograms. Well, there are 1,000,000 milligrams in 1 kilogram. So that's your factor of 10 to the 6 difference right there. If you do milligram divided by kilogram, you don't have to multiply by 10 to the 6 because you already have a 10 to the 6 difference. So another trick, in particular, I've seen chemistry teachers do this, that they like this. I personally live right here. Now, as far as knowing if you're using grams or if you're using mils, you have to read the question contextually. Do they want you to look at volume or do they want you to look at mass? It just depends on the question and situation, the data that you're collecting. So I have an example for you. Here it is. This was in the 1970s that people were using DDT as an herbicide. And it turned out that it was carcinogenic, really, really dangerous for living things, not only plants, but also animals. So here's an example that a bird was tested. They found 50 milligrams of DDT inside of 1,900 grams of tissue of this particular bird. And they wanted to know the ppm, what's the parts per million. So first thing I do is I recognize we're dealing with mass. So I want the same units of mass. I have milligrams and grams. Let's convert that milligram to gram so that we have the same unit of mass right here. So I took 50 milligrams. There's 1,000 milligrams in 1 gram. That means that we have 0.050 grams. 0.050 grams of DDT inside of this bird tissue. Now to find ppm, simply put your solute divided by solution. Okay, and you've seen this in our other problems when we're dealing with concentration. You find the solute, you identify that solution. So my solute for ppm was the DDT, 0.050 grams, divided by the solution. In this case, it's the tissue, 1,900 grams, and then you multiply that by a factor of 1,000,000 times 10 to the 6. And what do we get? The DDT has a concentration of 26 ppm. That means for every 1,000,000 grams of tissue, 26 grams are DDT. That's the ratio. That's the relationship right there. Okay, so there you have it on parts per million. The key is solute divided by solution, have the same unit, multiply it by 10 to the 6, done. You've got ppm. If we were going to do ppb, you multiply it by 10 to the 9. If it's a ppt, trillion, multiply it by 10 to the 12. Only difference. Okay, good work. Have a great day. Thanks.